Welcome guys. Let's see how to solve this problem we have on the board. Integrate 6x plus 4 all over x squared plus 4 dx. It has upper and lower limit. Let's see how to integrate it. Do you know you can factorize something here? Yes. So we now say that statement simply means integrate. We bring out 2. We now have 3x plus 2 all over x squared plus 4. That means we'll be having 2 brackets 3x all over x squared plus 4 plus 2 all over x squared plus 4. So we splitted what we have. 3x all over everything, 2 all over everything, you have this. That means that I am to integrate bracket 2 integration that means I will say 2 integral 3x all over x squared plus 4 plus these 2 will still go integral 2 all over x squared plus 4. That is, carry this to put it to both of them. That is what it means. But bring in this integral sign to each and every of it. dx. That means whatever we get here, we put our upper and lower limit here. Now, how do we solve this? We said to solve this, we recall that this is x squared plus 4 and this is 3x. So what I will do is to integrate this, I will say let u equals to x squared plus 4. Therefore, du dx will be equal to differentiate 2x, differentiate x squared, you have 2x. That is the power times the coefficient 2, the power minus 1. Differentiate 4, it will give you 0. Therefore, make the x subject of formula, it will give you du over what? 2x. When you got du over 2x, use it to substitute here. Therefore, we will be having 2 integral 3x all over u. What is my dx? Times du all over 2x. So you now see that 2 will cancel this 2. X will cancel this x. And it will give you 3 integral 1 over u du. That means since integration of 1 over x dx is equal to log x or ln x, that means integration 1 over u du will give me ln u. So you have 3 log what? U. Remember I said integration 1 over x dx gave us log x. So integration 1 over u du, where u replace this x, that will be giving us log u. You carry this 3 attached to it. What is our u here? We say u is x squared plus 4. So we clean this and we say x squared plus 4. So I have integrated this. I am to integrate this one now. So integrate this second one. I will say that I have 2 integral 2 all over. Here, I will divide everything by what? 4. I'll be having x over 2 all square, because x square is x square, 2 square is 4, plus 4 over 4 is 1. That is taking us to tan inverse of what? Function. Then I will say, therefore, let my u be equal to x over what? 2. So that we can replace this. Du dx. If I differentiate this, what is the coefficient of x over 2? X over 2 is something as 1 over 2x. Now, the coefficient of this x is what? Half. So differentiating x over 2 will give you half. Therefore, your dx times 1 dx equals 2 times du, 2 du. I will replace. I will say this means 2 integral. Okay, 2 times 2 integral 2 over u square plus 1. What is my dx? Times 2 du. What I will now do is, I will multiply 2 times 2, 4 times 2, 8. So, what I will be having is, I will say 8 integral 1 over u square plus 1 du. Now, it is important to know that when you come to tan inverse of function, integral, if you differentiate tan inverse of x, what it will give you? 1 over x squared plus 1, or 1 plus x squared. That is for tan inverse of x. So if you are to differentiate tan inverse of x, you will notice that it will give you 1 over x squared plus 1. That means if you are to integrate this, you will be getting what? Tan inverse of x, where the x is replaced with what? U. So what we will now have is that integration of this will be giving us 8 tan inverse of what? Our u. And what is our u? Our u is x over 2. Our u is x over 2. Okay? Now, having gotten this, we can now say that our final answer to this will be 8 tan inverse of what? X over 2. We have gotten our what? The integration of this, and we have gotten the integration of this. Okay. Now, what we are to do is to combine our answer. To combine our answer, the first one we integrated gave us 3 log x squared plus 4. Whereas the second one gave us, this one gave us 8 tan inverse of x over 2. These are the answers. But it has upper and lower limits, so we can't carry this, join it with this. We can't put plus c because it has upper and lower limits. So what we do, we'll put our upper and put our lower limit to each to get our final answer. Now, to get our final answer, we'll say carry 2, put here 2 squared 4. 4 plus 4, 8. We'll have 3 log 8 plus 2 over 2, 1. Tan inverse of 1, 45. Tan inverse of 1 is 45 because tan 45 is 1. since it is 45 to pi, if you want to convert 45 to pi radius, this is 45 degrees. To convert it to pi radius, you multiply by pi and divide by 1/8. I repeat, tan inverse of 1 is 45, that is 45 degrees. To convert degrees to pi radian, what you do is that multiply by pi and divide by 1/8. This, it will give you pi over 4. Okay? So that pi over 4 times 8. Pi over 4 times 8 will be giving you 2 pi. You have 2 pi. You now say minus, you carry 0 and put 0 squared, 0 plus 4 log 4, 3 log 4 plus, because we need to put 0 here. 0 over 2 is 0. Tan inverse of 0 is still 0. Then 0 times 8 is 0. So what we now have is what? Plus 0. We now say that this plus 0 is same thing as this. So what we'll be having finally is 3 log 8 plus 2 pi minus 3 log 4. We bring that 2 pi aside and say that this means times, okay, plus 3. From law of log reading, when I bring that 3, they have in common, and these two have log, I will say log 8 over 4, because of there is minus. There is minus linking 3 log 8 and 3 log 4. So that will be giving me what? 2. Because subtraction law of log reading say take their common log and divide the number. 8 over 4 will give me 2. That will give me that the answer will be 2 pi plus 3 log 2. Answer. To solve question number 2, you will notice that they are in product function, that is this multiplying to this. So we apply product rule. Now in product rule, for you to differentiate this, you use product rule. Now if you are to integrate something that is in product function, it means use integration by parts. That is, in solving this question, I will use at least 2 methods to solve it. 1, integration by parts. Method by integration by parts. Now, I'll call this my u, I'll call this my v. That is product function, right? Now, in integration by part, we say u, integration u dv is equal to uv minus integration v du. That means what I will call here is v, and what I will call here is dv, because of this integration by part formula. Now, my u is equal to s squared. My dv is equal to exponential x. If I differentiate u, what will I have? The power times the coefficient 1, the power minus 1, 1. I will have 2x. Then, this is differentiation of v equal to exponential x. Since we are given dv from the equation, to get v, we have to integrate dv to get v. Integrate dv, you will have v. And you will be having, if I integrate exponential s, it will still give me exponential s. That means integration of dv is equal to v and is equal to exponential s. Then I will carry these parameters and put it here. I will say this means what is my u? S squared times what is my v? V is exponential x. Minus what is my integration? What is my vp? My v is integration x. What is my du? du is what? 2x. That is my du. So that will be giving us x squared exponential x minus integration of 2x exponential x. Okay? Now next thing you have to do is you bring out these two. This will give you is x squared exponential x minus 2 integral x exponential x. It means I am to also what? Integrate this. Now I will call this my u and call it the v because I'm using integration by parts. My u will be equals to x. My dv will be equal to exponential x. Then if I differentiate u, I'll have the u equal to 1. If I integrate dv, I will have v and is equal to exponential x. Okay? Then I will still put it inside this formula. Whatever I get, I will package it and put here. I will say, what is my u from here? That implies my u is x, my v is exponential x minus integral. What is my v? Exponential x. And what is my du? 1. That will be giving me x exponential x minus integration of exponential x. Because this times this will give you exponential x. Now, that will give you, what is the integration of exponential x? Is still exponential x. We now say x exponential x minus exponential x. So we have integrated this. We say finally our answer will be write this. Finally, integration of u dv is equals to integration of x squared exponential x is equals to, what do we have? X squared exponential x minus 2 bracket x. Integration of this gave us this, exponential x minus exponential x. So what do we have finally? X squared exponential x minus 2x exponential x minus times is plus 2 exponential x. That is our final answer, plus c. Plus c. You can factorize. What do they have in common? Exponential x bracket x squared minus 2x plus 2 plus c. So either you leave the answer this way and put plus c, or you factorize. They have this in common, you bring it out. That is one method you can do that. Let's see a shorter method. Yes, we don't want to waste our time, so let's use shorter method and solve it. We'll write di because we are treating integration by parts. Now, what determines what should be at this side is which of these function, which of them can I put here so that when I differentiate at a point it will give me 0. You will notice that if I put exponential x here, exponential s, if I'm differentiating exponential s, it will continue to give me exponential x. So I will not put it here. But when I put x squared, if I differentiate, it will give me 2x. If I differentiate again, it will give me 2. If I differentiate again, it will give me 0. So this one gave me 0, so I can put it here. Then the second one, I will now automatically put it here. Integration of this will still give you this, will still give you this. You continue integrating till you get to where this 0 is located. Then put your sign accordingly, plus, minus, accordingly. Then connect this to this, connect this to this, connect this to this. So what are we going to get? This times this will give me exponential x. That means my answer will be this times this exponential x. This times this will give me x squared exponential x. This times this minus 2x exponential x. This times this plus 2 exponential x plus c. Or you factorize exponential x bracket x squared 2x plus 2 plus c. So with this method, it will make your work easier for you, not to waste your time. We go to question number 3. Let's see how to solve this question number 3. Now, this question you see, say let u be equals to exponential 2x plus exponential minus 2x. So let u be the denominator. See, it's what you are seeing up, you are seeing it down, only differ by minus. Let's see what we can get from there. We now say that if I differentiate that u, what am I going to get? For this one, I will differentiate the power, which is 2, then write exponential 2x. Then this one, I will differentiate the power, which is minus 2, then I will write minus 2x. Remember, if you are differentiating anything with letter x and power of 1, the coefficient will be the answer. That is reason why I said minus 2 and here plus 2. Then from here, we will be having 2 bracket exponential 2x minus 2 minus exponential minus 2x. So, wow. Fortunately for us, we could get what is here. That means we make our dx subject of formula. Therefore, our dx will be du all over 2 bracket exponential x minus exponential minus 2x. So we will carry it to replace this dx. We say therefore this means integration exponential 2x minus exponential minus 2x all over u. Then what is our dx? Du all over 2 bracket exponential x exponential 2x, please. Exponential 2x minus exponential minus 2x. And this will cancel this. That will give you have invisible 1 over 2. So you bring 1 over 2 out. Integral 1 over u du. Now in integration, in differentiation, when you differentiate log x, you have it to be 1 over x. When you integrate 1 over x, you have log x. Now here, 1 over u du is certain as 1 over x dx. That is, it's certain as integration 1 over x dx, where you replace this x. So automatically here will be log what? U, because you replace this x in this example. Then you attach your 1 over 2 to it. Then you say plus c. Plus c. Why are we putting plus c at this point? It is because it doesn't have upper and lower limits. When we solve this one, we didn't put plus c because it has upper and lower limits. So check our videos and see where we solve it. Now our u is taken to be this, so we replace equals to 1 over 2 log exponential 2x plus exponential minus 2x plus c, or log exponential 2x plus exponential minus 2x all raised power of 1 over 2 plus c. To solve question number 4, which is this one, you can see exponential x, exponential s, exponential, and you can see the x. Because of that, we say let our u be equal to exponential x, so that we know what we are doing. Let's see if we can get equivalent of the x, and if that equivalent of the x can cancel one of these. Du dx will be equal to exponential x, because when you differentiate exponential x, it gives you exponential x. Therefore, the x is equal to du over exponential x. You come here and replace it. You say integral exponential x all over 1 plus, what is our u? Exponential x, bracket 2 plus, what is exponential x? U, times du over exponential. So we are looking at a way to cancel this, and we see it can be possible. So this will cancel this. Now you will be having integral 1 all over 1 plus u, bracket 2 plus u du. So everything is in terms of u now. Do you know that this simply means integral bracket 1 all over 1 plus u minus 1 all over 2 plus u du. Question is, this statement and this statement, are they the same? Answer is yes. Let's check. If you look for their LCM, it will be 1 plus u, 2 plus what? 2 plus u. If this divide this, it will remain this. You have 2 plus u. If this divide this, it will remain this. You put your minus bracket 1 plus u. Opening bracket minus 1 minus u, minus 1 minus u. So 2 plus u minus 1 minus u. Plus u will cancel minus u. 2 minus 1 will give you what? 1. Making everything at the numerator to be 1 all over this. So going back to that. Okay? That means if I'm to integrate, I will take the integral sign to inside of it. Integral 1 over 1 plus u du minus integral 1 over 2 plus 2 plus u du. What will it give me? Now this is like asking you integrate 1 over x dx, where s is x. So that will be giving you log x or ln x. So this one will also be giving you log 1 plus u. This will be giving you log 1 plus u. Whereas this one will be giving you minus log 2 plus what? U. Following that scenario, or that example I just showed now, plus c. Someone can have it by applying law of logarithm as, someone can have it as, take their common logarithm, bracket 1 plus u all over 2 plus u plus c. So this can be the answer, this can be the answer.